Alright, today we're looking at inverse functions, and this is a pretty big topic that we're going to discuss throughout the rest of the course. First, a function can only have an inverse if it is one-to-one, meaning it passes the horizontal line test. And what you're going to see is that it is a reflection over that line y equals x. What we're going to focus on big time today is how to find an inverse function. And all we're going to do, you'll see, is essentially work backwards, but algebraically you're switching your y and x, which is why this kind of makes sense with flipping over that line, y equals x. And we'll talk down the road, but if two functions are inverses, if I do a composite function with the two of them, no matter which way I go, I should get back where I started. That's why it's an inverse. It undoes, or undoes, I guess, what you've already done. So let's see if we can find some inverse functions to start with. All we're going to say here is, can we find the inverse? Well, f of x, remember we say, is just a fancy way of saying y equals 4x. So when we find an inverse function, we say we switch x and y. And then we need to solve for y. How do I get y by itself? I would divide both sides by 4. So I should get x over 4 is now equal to y. Y is by itself, so x over 4, that's my inverse function. And that's how I will denote it. F inverse of x equals x over 4. Let's do the same thing for this one. I would say, again, y equals 2x minus 6. I would then switch x and y. X equals 2y minus 6. And I want to solve for y. X plus 6 will equal 2y now, and that means that x plus 6 all over 2 equals y. So my f inverse of x will now equal x plus 6 over 2, or if you prefer, you can make that x over 2 plus 3. That would be a fine way to look at it as well. Now, another way that we want to talk about this is not just with your algebraic, but also looking at common sense. What am I doing in this function? I'm taking a number and I'm multiplying it by 4. How would I work backwards from that? Well, I would then have to divide by 4 to get back where I started. Well, what am I doing? I'm taking a number, dividing it by 4. That's why they are inverses. Same here. First thing I do to a number is I'm multiplying it by 2. Then I'm subtracting 6 from it. If I work backwards, I would need to add 6 back and then divide by 2. Well, look, take a number, add 6, divide by 2. So we call these our dance steps, just kind of working yourself backwards, and mainly because you like seeing me dance in class. How we would work backwards of this one should be that, well, what am I doing to start with? I'm multiplying it by 7, then adding 3. That means I should be taking a number to work backwards, subtracting 3 first, and then dividing it by 7. And you can check that. If it was y equals 7x plus 3, you switch it, 7y plus 3. And from there, so x minus 3 equals 7y, divide by 7. X minus 3 over 7 equals y. We get the same thing either way. So let's take a look at another more complex one that we can look at. Let's look at f of x equals the square root. So let's first look in order. What are we doing? First thing we're doing is we are multiplying a number by 2. Next thing we're doing then is we're subtracting that number by 3. The last thing we do is we take a square root of that. So let's look. If we were to reverse this, what does that mean we would do? Well, first thing is I would take a number and I would be squaring it. The next thing I would do would be to add 3. And then the last thing, the opposite, would be to divide by 2. So let's take a look how that works as we're doing the algebra. Y equals the square root of 2x minus 3. Switch it. X equals square root of 2y minus 3. Let's solve for y. The first thing I have to do, this whole thing's under a square root, so the first thing I'm going to do is square both sides. And that gets rid of the square root. Well, what was the first thing I said over here I would do? I would square the number. Well, there you go. I've already done it. Next thing I need to do to get y by itself is to add 3 to both sides. And again, the next thing on our list is to add 3. That's step number 2. And then the last step would be to divide by 2. X squared plus 3 over 2 equals y. And the last thing we said we have to do would be to divide by 2. So that's what we have right there. This is what our f inverse of x ends up being. Now, if we were to graph those, this is the picture we would end up with. Our f of x is here in blue, and our f inverse is this yellow function, this parabola. You should notice it's really not a reflection of this, of each other's graph. If anything, it looks like maybe this graph should come down something like that, and then it would be a perfect reflection. Well, the reason is because if we take a look, this function does not pass the horizontal line test. It can't have a full inverse. Because if it did, looks what would happen. I would not pass a vertical line test, so it wouldn't be a function to begin with. Now here's something we kind of want to look at though. Looking at how these functions are graphed, let's look at their domain and range. The domain of this function, it starts at, well, at 3/2 and goes on to infinity. Remember, we can tell that immediately by saying when is this bigger than or equal to 0. That's when 2x is bigger than or equal to 3, so x is bigger than or equal to 3/2. Okay? And as we're looking at the range, well, it's a square root. A square root must always be positive or it could equal 0. So 0 to infinity is our range. Let's look at the same thing over here. Let's look at the domain and let's look at the range. Especially the range is what I want to focus on. The range of this graph, it starts at, well, let's take a look. 3/2 and goes up to infinity. Where did you see that before? Guess what? The range of this function is the same as the domain of my other function. So this f inverse of x has a range which is the same as the domain. And guess what? That means that the domain should be the exact same. So I should take this range, and that's what my domain needs to be. I'm going to essentially restrict this domain so that I have a one-to-one function. And to do that, I'm going to make it from 0 to infinity. I'm pretty much going to just erase that half of the function. Now I can have a perfect reflection. Now I can have my domain and range line up the way that they should. So this is something that's really big. We're going to say that the domain of f of x is the same as the range of the inverse. And the range of my function is the domain of my inverse. So, just to take a look at another example of how to do this. Before I even find the inverse, the first thing I want to say is, what is the domain, what is the range of this function? Well, the domain here is all real numbers, correct? You can plug in anything. The range of this graph, any number I plug in becomes positive, then I subtract 5. The lowest number will be 5, so 5 to infinity. Now, what does this graph look like? Well, if I were to graph this, it would look something like this. Is that a one-to-one function? No, so I cannot take the inverse of it. But like we said in the last one, I can restrict the domain, and that's what I'm going to do. To make it one-to-one, I'm just going to kind of take away this left half of the graph. And when I do that, if I say, well, I want x only bigger than or equal to 0, that means now my domain is going to be, instead of all reals, it'll be 0 to infinity. So without doing any work of finding the inverse, I can find its domain and its range. Its domain should be the range of my function, -5 to infinity. Its range should be my domain of the original function, 0 to infinity. And then I can find, the way I've done before, if y equals 2x squared minus 5, I can actually find the equation now. I'm going to switch it. X equals 2y squared minus 5. So x plus 5 equals 2y squared. I should then, from there, divide both sides by 2. X plus 5 over 2 equals y squared, which means the square root of x plus 5 over 2. That is my f inverse of x. That's what y equals. The square root of x plus 5 over 2. Now to look at this function and actually check its domain. Same thing we've done before. I want the inside to be bigger than or equal to 0. I would multiply both sides by 2. That means x plus 5 is greater than or equal to, 2 times 0 is still 0. X is bigger than or equal to -5. Exactly what we wanted. So that's a really crash course on inverse functions, and we're going to be doing a lot of them as we move forward in the year.